All right, dividing complex numbers. This is kind of how this is going to work. The problem with this situation right here is that we want our complex number to be in the form of a plus bi, the real portion times, plus b times the imaginary portion. So we can't have this I down here. So to get rid of it, what we're going to do is going to multiply by 1 using 3i over 3i. And hopefully you can see what's going to happen here. If I do that, what's going to happen here is we get 3i times 3i, which is 9i squared, over, here we're going to multiply this here. So 3i times 4 is 12i, isn't it? And then 3i times 9i is 27i squared. This is where your knowledge of the imaginary number comes in really handy, is that if you, hopefully remember that I squared is equal to negative 1. So what we really have here is we have 9 times negative 1, and here we have 27 times negative 1. So we have 12i plus, actually minus 27 all over negative 9. This is the part that seems to bother people. So let me just kind of work this out a little bit slowly and remind you that if we had a fraction like 1/5 plus 3/5, we have a common denominator. We wouldn't add the denominators, but we would add the top two. We would add the numerators, wouldn't we? So we'd have 1 plus 3 up here, and I know that's 4. But what I'm saying to you is, given this, if I have this situation here, and I can convert it back into, this, and that's what I want to do with this. I want to look at this thing like this. I want to look at it as 12 over negative 9, and I want 12i over negative 9, and I also want to look at it as negative 27 over negative 9. So negative 27 over negative 9 is positive 3, right? Plus 12i over negative 9, otherwise known as minus 9. So there's our answer. All right? So I know it's kind of a pain in the neck, but it can be done, and this is how we have to work this out. We're going to do something similar on this problem. Here what we're going to use is we have a we have a complex number in the denominator. We can't have that there. So what we're going to do is we're going to multiply by the complex conjugate. So complex conjugate by the complex conjugate, which is just to say, instead of 2 minus 3i, we're going to use 2 plus 3i. What we're doing is we're creating difference of squares here. And then 2 plus 3i, because we're multiplying, have to multiply by 1 to keep all this good, right? When we multiply this out, we're going to get 4 minus 9i squared. That's the bottom piece. So 4 minus 9i squared is the bottom. At the top, we're going to get 7 times 2 is 14. 7 times positive 3i is positive 21i, isn't it? 4i times 2 is 8i, I hope. And 4i times 3i is plus 12i squared. And we're going to clean that all up. Let me see if I did my math here. 7 times 2 is 14. 7 times 3 is 21. 4 times 2 is 8. 4 times 3 is 12i squared. So what we're going to do is do a little bit of work here, remembering that I squared has a defined value of negative 1. So we can take this out and make this negative 1. So positive 12 times negative 1 is negative 12. Get rid of this, right? And then we can start to simplify. So I'm going to simplify this out a little bit. And we get 14 minus 12 is 2. So I use the 14 and I use the 12. And 21i plus 8i is 29i, isn't it? 29i all over. And going to do the same thing down here, right? We're going to say that our I squared that we had here is worth negative 1. So negative 1. Negative 9 times negative 1 is positive 9. And so this turns into 13. Now all we're going to do is break this thing out just a little bit. And we're going to get 12 over 13 plus 29i over 13. And there's our solution. All right? This is not especially simple, but you can definitely do this. So take your time and be patient with yourself. All right? Good work.